Coming up on this version of the FRC Open Alliance Show, 9062 Critical Circuits is here from Ontario, and hopefully you've seen all the great content they've been creating. They have a ton of YouTube shorts out there documenting their progress as they go throughout the way and impacting people from all over the world, showcasing what FIRST is. We'll be diving more into their design and manufacturing processes, some prototypes they've been working on, and then going into maybe a couple of electrical issues they've been having, what they're looking at doing from a programming side, and talking more about their partnerships, some of the cool collaborations they've been doing, and of course a bit more about all this awesome media content that they've been putting out as well too. So let's learn more about Critical Circuits and their current progress here on the FRC Open Alliance Show. Let's welcome on to the Open Alliance Show, 9062 Critical Circuits coming in from Ontario. They're competing weeks 2 and 3 and a lot of great stuff. Hopefully you've been watching all the awesome content they've been putting out on shorts and reels as well too. But welcome in everybody. Why don't you introduce yourselves, let us know what you're doing in your team, and we're going to jump right into some of your design and manufacturing processes.
Hello, I'm Max. I'm part of leadership and I do a bit of everything, but mostly designing.
Hi, I'm Martin and I'm a design lead in our team.
I'm Raymond. I'm the programmer for our team, and I'll be talking about the algorithm we already designed for the robots.
Hi, I'm Tola, and I'm going to be talking about partnerships.
All right. So what we want to do this season is we want to build a robot that it's simple, but it's effective. So different from our previous robot from last year, but when we saw the game, we are really shocked because this is not what we imagined at all. So we straight apart from the goal, and we went for work 70% of the time, but can still very competitive. So at the kickoff, we got a list of priorities. And one of them is deep climb, because early on we figured that deep climb would be very important, of how 12 points of deep climb compared to 15 points for RP, and we found it to be meta as many other teams did. You can see from our shorts that our mentor from early on has a very good climb that going to be almost our final climb for this year, but
we'll talk about it more about it later, I guess. And for in one of our priority lists is also only scoring L1 to L3, which I think is pretty significant to our team. And one of the big reason for that is this year is our first time doing an elevator, and we don't have any full confidence in terms of building and fixing it during a competition. So at the start of the season, like between day 1 and day 2, we know that we can only do a single stage elevator, and this factor limits us to only do L1 to L3. However, we found out that in Rembrandt's 4481 Open Alliance videos that their coral intake can actually potentially shoot to an L4 position, which opened the gates with some of our design.
Talk about the prototype.
So we can talk about some of our prototype about in the early on of our season. So one of our prototype for Coral is actually our 2023 off-season intake, which is a claw basically. So the original prototype is just horizontal. The Coral will horizontally go into our intake, but however, the dimension isn't really exactly right, and we kind of scrapped this idea after around 2 tries. So after that, we moved on to our second prototype it's like a external intake of our Coral. We use this part, which we have already disassembled, and I believe we have posted. Yeah, exactly. We basically have 2 horizontal rollers on on out external of the coral, and we test it out with flanges, and also we test it out with some 360 rollers. So there's a prototype that we tried that we have 4 different size of rollers that can keep us like easily intake from the coral station. However, after building the whole prototype, we realized that the mechanism is way too heavy for our mechanism or our overall design, especially as we want to make the whole elevator and the carriage as light as possible. So for our 3rd to 4th iteration for our coral intake, we moved on to a 3D printed version of this internal intake, which is inspired by Rembrandt's. They're a great team, of course. And this basically goes into the coral and securely attached to it. And this can also act as an intake and an outtake at the same time. And yeah, which gives us a really good idea of how light can this mechanism be comparing to the one previous that we need 2 way bigger plates. That's this and our final design, which we'll talk more about later, is we are using this intake as our outtake and intake for coral. Yeah, we want to talk about the client.
Yeah.
One of the things, real quick, if I can ask you, is that you mentioned earlier that, like, hey, we saw Rembrandt's and they were potentially maybe shooting coral up to level 4. Is that something you have actually like tried and tested yet, or is that one of those like, hey, if it works, great? Because I love your idea of like focusing on levels 1 through 3. We had another team on Open Alliance Show that said the same thing too, where hey, you have to set those priorities sometimes. But have you done any sort of testing for level 4 scoring, maybe with this type of intake or grabber?
We didn't do a entirely testing on that, but because in our priority list, our scoring L4 is what we want comparing to what we what we have to complete in this competition season. So we kind of prioritize later, and we want to try it out after we build the robot, which because we're not prioritized it at all in the season.
Yeah, makes sense.
Yeah.
So for RP, we need 4 different levels completed. So that's why we also going for the ball scoring, particularly the processor, because we attending week 2 and week 3 consecutively. So we wanted to prioritize what we can do consistently and steadily, and to improve during the after season until we get to DCMP if we can at all. So as Martin said, L4 is what we can test during that period of time, that huge chunk of weeks that we can practice and test that at all. So that's just another plus, but we don't prioritize at all. For the processor, we chose that again because it's reliable, but we figured out in the early that we want to do the tube or the coral more. So that's what and we also want to prioritize um, reducing the amount of time between cycles as much as possible. So that's why the design is became to be. We can intake the ball as fast as possible, and then to score the processor at the same cycle. We don't have to. One of the first iteration of it is we're gonna take like a pole, and then we're gonna push the ball out, and then we're gonna intake. It takes a lot of time, so that's why we went for this design, because we are able to, hey, get the ball in, score it, and then we can score the on a 1.5 cycle time, and that's really it's effective, and that's what we want, because we want more practices during this season, and I think it's not hard to achieve with the time. We can hey, not going for two-stage elevator, going for one stage. We have more time to practices. And yeah, that's our idea of the season constraints. But because of those constraints, we can give more time for the drivers for the drive team to practice. That's why we want to prioritize this season more on.
So
Yeah.
is this actually looking to pick up from the ground as well too, or is this specifically for getting LG off the reef?
Yeah, this is also possible for pickup on the ground because there's we are imagining there's a scenario that our alliance can only like drop the ball on the ground, and we can, and I think we need the ability to pick up also on the ground and on the reef. So that's the one of the ability we prioritize. Yeah.
Let's talk about some of your progress in terms of what you're doing for programming right now and electrical coming together. What's that been like for your team?
We're having mainly two issues. First is with this radio. We have a total amount of 3 radios, and 2 of them are broken. And so for a new radio we got, there's no, the lights are not on the BS part, which is a drive station. And also it also happens to our other radio of our power cycle on the robot. And also the next part is about our intake. You see, we having a time of flight sensor here because last year when we were designing the conductor, we didn't consider the wire too much, so that it fell off a lot during competitions. And this year we are using can and crimpers, so that it's more stable than regular 2-pound connector. And for automation, what you can see is we're having a wrist on the elevator, so that there's a chance is going to touch the 2x1 on the top of the elevator. We came up with 2 solutions, and so the first one we already gave it up, but we did make a lot of progress on it, but we just found it's too hard. And so basically we do the collision detection with we approximate all our robot mechanism to a circles. Like the intake can be considered as a huge circle or just different circles on that extended part. And we use a rotation matrix for that. And because we are rotating the x and y coordinates, you can't just use cosine and sine formula. And with the rotation matrix, we can get the final position after giving the rotation matrix our angle for the arm. And that's how we do the collision detection part. And since we approximate by a circles, and it's really easy to do. And as industrial use, they use the 2 radius, detect if the sum of the 2 radius for the 2 circle, you're detecting if they're touching each other, and to say if the sum of their radius is larger than their distance, and that's a condition. But also we also need some algorithm called A star or RRT to generate the path to go through those positions, because we got the collision function, we also need something to find the path. Like if we want to go from the height of 0 centimeter to 75 centimeter, and now our current angle is 0 degree, so that it will generate set of positions like 20. That's what 6328 does for their 29.3 robot. But they did it with numerical optimization, which we don't have that much time to spend on Python because I'm mainly using a Java user. Also for our autonomous part, they did automate this year, and so there's a 30. I remember it's around 30 positions. So we want to avoid this step. We also did it with the rotation matrix. We generate basically just input a position of the reef, and we flip it for the red lines. And for each reef, we call it each part of the reef a reef station. And we have station A to station F, and we input the distance, and the program will compute by itself. We also made the open source on GitHub for any team if they are interested in it. And for the automation part, Pathfinder doesn't have any automation command. So we did it by we changed some line of their pathfinding command, and we compile our own library. It's also public on GitHub. And I think that's all for automation.
Yeah, and you can find a lot of those links, by the way, on their Chief Delphi build log, so make sure you do go check that out as well, too. And one of the things I would love to talk about as well is your team has done a great job documenting your progress as well. I mean, obviously on Fun, we love video content for things, and your team has been doing such a great job with that as well. Can you talk a little bit more about your approach to how you're doing media and team collabs and how all that's working for you on 9062?
Okay, so we started off with the kickoff live stream, which was really successful. So people tuned in to see the build process. Hundreds of people tuned in to see the process. I'm planning on donating the parts for the kickboard to rookie teams in the tournament match. Multiple shots were posted on YouTube, and we have a lot of people watching it. Like 1.6 million views and counting since the kickoff, allowing people to families and friends to see what we've been doing, what we've been up to, keeping them updated. Streams have allowed us to connect to viewers and collaborate with 9580 and chat with teams like 930 and 8729. We borrowed some gearboxes from 5406, another Open Alliance team. We helped 5406 build their practice fields, received wheels from 3161, Trinic Titans, and we've been pleased with how they've worked. They're an Open Alliance team with great videos, and we're very grateful for the wheels because they've been really helpful basically. And today we kind of had like an interview too for the school. So basically the school, the parents can also see what we're doing as a robotics team. So basically media has been really good. Everything is updated on the YouTube, lot of views and counting. So yeah, it's really good so far.
One of the interesting things too with vertical based content as well is that you're hitting kind of a different audience with that as well too, right? When you have vertical content, you're really getting a great opportunity to reach people outside of FIRST to showcase to them what it is and really kind of spread that impact as well too. So I think, to me, there's such great opportunities for teams out there to utilize vertical based shorts, reels, TikToks, things like that to reach such a huge audience that is maybe not even knowing what FIRST is in the first place, right? And showcasing like, hey, come in and check out what FIRST is as well. So kudos to your team for doing such a great job with that. I know you'll continue doing the great work with that as well too, and I can't wait to see all the future content that you keep doing. So Critical Circuits, thank you so much for taking the time to tell us more about your progress with that. As mentioned, you're competing weeks 2 and 3, so we can't wait to see how that happens out in Ontario. So good luck the rest of the way, and keep following their build log for more continued progress on what they've been working on. Thanks a lot, everybody.
Thank
Thank
you.
you.